Okay, I want to look at problem a problem from section 3.4, and this is problem 4a. And on that, we want to show that the function f of x equal to 1 over 1 plus x squared is a contractive mapping. Okay. This is a nice example because it's a good application of your Calc 2 or Calc 1 to this to the material in this course. And so what I'm wanting to do is to show that to use the mean value theorem to show that this is a contractive mapping. And so this requires a little bit of care to do. First off, notice that this is differentiable on the whole real line. And because of this, we can say that if we take any x and y that are any two real numbers, then f of x minus f of y is equal to f prime of c times x minus y, where c is between x and y. Okay. Now, so if we have this, okay, and we look at the absolute value of x minus f of x minus f of y, this is equal to f prime of c times x minus y. If we can say that f prime of c is less than or equal to lambda, where lambda is a fixed number which is strictly less than 1, then we can get that this is a contractive mapping. Okay. So first of all, let's see, we can calculate that f prime of x is equal to negative 2x over 1 plus x squared. Now, I've done this. I haven't shown you the calculation on this. I expect you to be able to go through the process and take a derivative to get this. Okay. Now, what we want to do is to see, to look at this and show that it actually has a maximum value, and that maximum value is actually strictly less than 1. And so here, just to help us thinking about it, I'm going to say let's let g of x be equal to negative 2x over 1 plus x squared, quantity squared, and to find the maximum value, okay, find the max of gx on negative infinity to infinity, the real line, and to find the minimum of gx on negative infinity, positive infinity. Okay, because and we'll be able to do this just using calculus stuff, right? So again, we've got g prime of x. We calculate the derivative, and I expect you to be able to do this on your own. It's been a while since I've taught calculus, so I had to redo and check my calculations 3 or 4 times just to get back up to speed. But when I did, it's 6x squared minus 2 over 1 plus x squared cubed. Okay, so our denominator, okay, 1 plus x squared is never going to be equal to 0, and in fact 1 plus x squared is always going to be strictly greater than 0. So this simplifies our analysis of this, because to find our maximums in analyzing our function, we find where the derivative is 0, but then we also go through looking for what the sign of that derivative is. Okay. Now, I got my derivative is my numerator, which is what I'm going to analyze here, is 6x squared minus 2, okay, and 3x squared, excuse me, that'd be 2 times 3x squared minus 1, okay. Now, this is a parabola, okay. And what do I know about this parabola? Okay, it's a smiley parabola. It's going to look in general like this. This is an even function, so it is going to be symmetric around the y-axis. Okay. When I set this equal to 0, I get my x is equal to plus and minus 1 over the square root of 3. Okay. So in analyzing my g, let's see, my g prime of x, okay, let's see, it's going to be positive, okay, until we get to the negative 1 over the square root of 3. It will be negative between negative 1 over the square root of 3 and positive 1 over the square root of 3, and then it will be positive thereafter. So my function g of x, right, is increasing till it gets to that point. It decreases between and then increases again. Okay. Now, let me write down my function. Let's see, g of x again. Right? It's equal to negative 2x over 1 plus x squared quantity squared. Well, so it hits a negative here and increases after this point, but it's negative all on this side. So it increases, but it's not going to increase without bound because it's bounded above by 0. Over here, we're similarly for x negative, this will always be a positive quantity, and though in this direction we go off infinitely far, it'll never get below 0. So this in fact is my maximum, and this in fact is my minimum. And because this function is symmetric about the origin, the value it attains here is the same as the value it attains here. We can plug it in. Oh, actually not the same, it's the negative, but you see what I'm saying. G of negative 1 over the square root of 3. We go through that calculation, and that will turn out to be, okay, 9 over 8 square root of 3, which is less than 1. So I let lambda be equal to 9 over 8 times the square root of 3. And so going back now to our original function, we have that f of x minus f of y is less than 9, 8 square root of 3 times x minus y. And you can put these numbers in a calculator and see that this is in fact less than 1. And so this is a contractive mapping.